Hello, Algebra 2 students. This is page 1 of your Unit 1 review. Notice at the top there are some vocabulary terms that you need to review. Don't skip over these words. Instead, you should write them on a sheet of paper and try to write your own definitions for them. If you have any trouble, you can refer to your notes or you can look them up. After you finish with that, move on to number 1. Write the domain and range of each relation in set notation and determine whether it is a function. So in number 1, your domain is the list of all your inputs or your x values. So they are here. You can write them in the order that you see them, but your teacher would probably prefer that you write them in numerical order, starting with the smallest, -4, and continuing up to the largest, 1, 2, and 4. The range is going to be the set of the y values, and the same thing goes for the range. Your teacher would probably prefer that you write from the smallest, -3, up to the largest. Let's see, so we have several 2's, but first let's write the 1. Remember that if there is a repeat in your range, you only want to write it one time. Let's see if we got everything. 2, -3, 2, 2, and 1. Yes. The question is whether this relation represents a function. If every x has just one y, then it does represent a function. In this case, we have no repeated x's, so yes, this is a function. If you did have a repeated x, for example, if you had another 4 as an x, just like you had a 4 here, you would want to check and see, did you get the same output, like a 1? That would still be a function. Or did you have a different output, like a 2? That would not be a function. But that's not the question that we're answering, so I'm going to erase that one. In the second example, your domain comes from your graph, and because you have arrows pointing in both directions, your domain starts all the way over here at -infinity, and it ends over here at +infinity. So your domain is -infinity to +infinity, or in set notation, you might have all x such that x is an element of the real numbers. For your range starts at the bottom at -infinity, and it continues up to your vertex up here. On your copy, it might be difficult to read the numbers on the grid. It turns out this y value here is 4, so your range is -infinity to 4. In interval notation, you might write that as -infinity to 4 with a square bracket. In set notation, it would be all y such that y is less than or equal to 4. To determine whether this is a function, you're still looking to see if every x has exactly one y, but a shortcut on a graph is the vertical line test. If you draw a vertical line, it should cross your function only one time. If you draw a vertical line that crosses the function more than one time, it actually is not a function. In this case, we cross just once, so yes, this is a function. Okay, in number 3, we need to find f of 3. And here's my function f. So what you want to do is you want to substitute 3 for the x. -4 times 3 plus 2. -4 times 3 is -12. And -12 plus 2 is -10. So f of 3 equals -10. In problem 2, we want g of -2 divided by f of 2. So I like to find these separately and then divide. G of -2 is going to be 2 times absolute value of -2 plus 3. F of 2, we go back to the f function, -4 times +2 plus 2. So in your numerator, absolute value of negative 2 is positive 2. So I have a positive 2 times a 2, that gives me 4 plus 3. In the denominator, I have negative 4 times 2, that's negative 8 plus 2. And then let's add, and I have 7 over negative 6, which is negative 7/6. In problem 5, we're going to find the difference between two values. So f of negative 1 is negative 4 times negative 1 plus 2. Negative 4 times negative 1 is 4, plus 2 is 6. G of negative 5 is going to be 2 times absolute value of negative 5 plus 3. The absolute value of negative 5 is 5, times 2 is 10, plus 3 is 13. So I have 6 minus 13, which is negative 7. Okay, moving on to variation. In problem 6, y varies directly with x, and y is 2/5 when x is 4. So whenever you see varies directly, right away you want to write down y equals kx. So when I'm asked for the constant of variation, that is the k value. So to find the k value, we substitute 2/5 instead of the y. I don't know the k, that's what I'm going to find, and that's times 4. So to solve for k, you divide both sides by 4. If you're doing this on a calculator, make sure you have parentheses around your fraction. So you would type parentheses 2 divided by 5, close parentheses, and then divide by 4. If you're doing this without a calculator, remember that dividing by 4 is the same as times 1/4. So k would be 2/5 times 1/4, which is 2 over 20, and that simplifies to 1/10. So k equals 1/10. Once you have k, to write your variation equation, you just put that number instead of the k. So that would be y equals 1/10 x. And finally, you can find y when x equals 35 by substituting 35 in for x. So you have y is equal to 1/10 times 35, and you should get 3.5. Okay. In problem 7, y varies jointly as the product of x and z. So varies jointly is a lot like direct variation, but you have more variables. So you have y equals k, x, z. You're still going to try to find the k value, so we're going to substitute in 16 for the y. I don't know the k. I know the x is 2, and the z is 32. So first I multiply 2 times 32, and I get 16 equals k times 64. And to get the k by itself, divide by 64. So k equals 16 over 64, which simplifies. So k is 1/4. So then my variation equation is y equals 1/4 times x and z. X, z. So finally, I can substitute in values for x and z and find y. Y equals 1/4 times 20 times 9. Well, 1/4 of 20 is 5, and then 5 times 9 is 45. Okay, and we're almost done with the page. In problem 8, The amount of money raised at a charity fundraiser varies directly with the number of attendees. So the money varies directly with the attendees. So normally I would write y equals kx. But here it could be helpful to use m for money. K will always be k. And then it varies with the attendees, so I'll use A for attendees. The amount of money raised for 5 attendees was $100. So I'm going to put 100 for the money equals K times 5, and now get K by itself by dividing by 5 on both sides. So I get that K equals 20. And now my equation is going to be money equals 20 times attendees. So finally I'm asked how much money will be raised for 60 attendees. So you substitute 60 for your A. So money equals 20 times 60, which would be $1,200. That's the end of page 1. If you want to see page 2, open the new video.